Hey guys, so I just wanted to make a quick video from lesson 14, and so I'm going to go through question number 10 that had some people that were a little bit confused about it, so I'm going to go through how to do that one today. So you're asked to analyze the graph to the right to address the following about the polynomial function it represents. So you're just asked to answer parts A through E, and so we're going to go through how to do that. So, excuse me. So you're given a graph over here to the right. So a lot of this is looking back at your known basic graphs of functions. And you know that this is the graph of f of x equals x cubed, I believe. Let me see. Let me just make sure. Yeah, which the known basic graph for that looks like this. Whereas this guy's a little bit different. So basically, you want to compare it to your known basic graphs, and that's basically how you're going to answer these problems, but you're also going to use the information given on the graph. So knowing that, we know that when we compare this to a known basic graph, the degree of the polynomial function is odd because the end behavior as well. So the end behavior, it starts in one direction but ends in the opposite direction. That also tells you that the degree is odd, because if the end behavior were to start in the same direction, then the degree would be even. And that's just kind of a known basic rule as well. So because the end behavior begins down and ends up, so they're going in opposite directions, we know that the degree of the polynomial is odd. So then we're going to think about the leading coefficient. Well, because this is doing what the known basic graph would do, the leading coefficient is positive. If we had a graph that did something like this, then the degree would be negative, because it would be doing the opposite of a known basic function. And so just knowing that information, we can surmise that the leading coefficient is positive. Then you want to find the value of the constant coefficient. Well, that is simply where it crosses the y-axis. And we can see right here that it crosses the y-axis at y equals 0. And so that's how we got the value of the constant coefficient is y equals 0. That's our y-intercept. So then you're asked to evaluate the real zeros. Well, that is simply where it's crossing the x-axis. So it's crossing it in 3 locations. It's crossing it at x equals -4, at x equals 0, and at x equals 1. And so to evaluate, the leftmost real zero is x equals -4, so that's the farthest to the left. The real zero between the leftmost and rightmost real zeros is x equals 0, because it's crossing the x-axis at x equals 0. And then the rightmost real zero is at x equals 1, because that's the final area where it's crossing the x-axis. Then you have to evaluate the multiplicity. Well, again, if it's crossing the x-axis, it has odd multiplicity. If it simply touches the x-axis, it has even multiplicity. Those are the rules. So given that information, it's crossing the x-axis at every single one of those points. And so for that reason, each one has odd multiplicity. Now the last part is figuring out what your equation is. Well, your leftmost, the way you evaluate it is it's always x equals c, therefore, x minus c, therefore x equals c. And c is your real zeros. So in this case, we have a -4, a +1, and a 0. Well, the x equals 0, that's just going to be the value x. For x equals -4, that's going to be x minus c, or x minus -4. And then for x equals 1, that's going to be x minus 1, right? Because c equals 1. And so you can evaluate all of this and plug it in together. Minus 1. And that's how we ended up with c as our answer for this. Just because we have an x equals 0, we have an x equals -4, and we have an x equals 1. And that goes along with part D. And that's it. That's all you have to do to solve this one. If you have any questions, please feel free to reach out. Otherwise, thanks for watching.